Alright guys, we're back working on the foot peg project for my flat track motorcycle. As you can see here, here's a quick picture of what it came out like. So I'm going to walk you guys through the process that I used to make this foot peg. So I was at the school, laid out my marks, cut it on the bandsaw, cut it on the horizontal bandsaw, and we're here at the machine. We need to power up the machine, so we're going to release the emergency stop. We're going to cycle the door, and we're going to click power up. When the machine is in the power up mode, it's returning all of its axes to their home position. Once it's returned home, we hit handle jog, and we're actually going to perform a spindle warm up. So we're going to hit list program. We're going to look for the folder 9000. We're going to scroll over, and then we're going to scroll down with the cursor to find the spindle warm up program. There it is right there. We're going to copy it to memory. And there we go. There's our spindle warm-up program over on the left. What we need to make sure that we do is we set our spindle to 50% as we're running that spindle warm-up program. There's the 50% right there. And then we're going to go ahead and click cycle start. That takes about 20 minutes for the spindle to warm up. We're going to get our program loaded in. So we hit list program. We're going to go over to USB, and then we're going to find our program that we want to save to our memory. F2 to copy. We're going to copy it to memory. There's the program right here with all of our tools listed. So the next thing that we're going to do here is we're going to make sure that we clean the vise out and wipe down the parallels to make sure there's no chips. Any chip on any surface inside of that vise could throw our part off by, thousandths of an inch. We're going to open the vise up, and we're going to get our material loaded in the vise. We want to make sure that the material is centered in the vise. That way when we clamp the material in the vise, the clamping pressures are nice and even all the way across the part. But before we get it loaded in there, we want to make sure we deburr all of the edges of the part. After I cut it on the bandsaw, it still had a little bit of a burr to it. Wipe the part down, make sure there's no chips, and we'll get it clamped in the vise. And then we want to also set it with a hammer, a dead blow hammer, and we want to check our parallels to make sure that they are not loose. Now I already have tool 1 loaded in the spindle, so we're going to zero out tool number 1. We're going to indicate that on the top of the material. I jog the spindle down in Z at 10 thousandths rate until I get close, and then I creep up on a piece of paper using the 1,000ths feed rate, and I'm going click by click until that tool grabs onto the piece of paper. MDI T2 ATC forward to get to tool number 2. I have to load tool number 2 into the spindle. I want to make sure I hold on to it at the bottom and that I have the squares lined up with the drive dogs of the spindle. Press the button, bring it up into the spindle. Handle jog Z to get it down close to my part. 1,000ths feed rate, moving the paper side to side until that tool grabs onto the piece of paper. MDI T3 ATC forward. Just checking which tool is tool 3. Tool 1 is a 3-inch face mill. Tool 2 is a 1/2-inch end mill. Tool 3 is a 1/2-inch ball end mill. Tool 4 is a chamfer mill. Tool 5 is a 3/8 drill. And tool 6 is a 1/2-inch diameter drill. This is all basically rinse and repeat, right? We're pretty much doing the same process over and over again. And it's the same way on multiple parts. Most parts that you're going to make, you're going to have the same process. There's a little different way that we could be doing some of these different operations here, which, as you guys know, you've seen in class before. But this is just a general overview tutorial on how to set up our Haas CNC machine. Remember, we need to have the door closed in order to do a tool change. It locks that door closed when it's doing a tool change. Now, as you can see, that this tool didn't really fit, so I'm going to raise the spindle, or I'm going to, move the table over in X so that this tool will fit up underneath. And what I'm going to do now is just double check that I have clearance. That was a longer drill in a drill chuck holder, so that doesn't give us a whole lot of clearance, but in fact it had maybe 20 or 30 thousandths of clearance. Now, I wanted to make sure that it had clearance when it was at the tool change height, because anytime that we go to do a tool change, that part could potentially come in contact with that tool if it doesn't have enough clearance. Once again, just double checking that we have plenty of clearance. And here's tool 6, loading that up in the same fashion. Next up is going to be getting our work offsets set up with our Renishaw probe. I have the probe over the top of the back left corner of our part, In order to get to a probing cycle, I'm going to hit Edit, Edit, scroll over to VPS, down to Probing, over to Work Offsets, and down to Outer Corner. I want to make sure I have corner 4 selected. Moving 1 inch over and 1 inch back is fine, but I want to make sure I go down negative 0.25 inches in Z. Copy that to memory. And then I can go ahead and hit cycle start and let the probing cycle start. That's going to find both my X and Y axis. But what I also want to do is move my offsets that I've selected in Fusion 360. So I'm going to handle jog using the distance to go numbers, right? Using the distance to go numbers, I'm going to handle jog both an X and Y, a specified distance that I selected in Fusion 360. Once I have that, I'm going to go to Offset and hit Part 0 Set on both my X and Y axis. I also typed in negative 20 thousandths for my first operation Z offset. Now that I have my tools set up, I can go to Memory, Cycle Start. Here's Tool 1, 3-inch face mill. It's going to face off our part at negative 20 thousandths in Z. Tool 2 is going to be our 1/2-inch end mill. And that's going to be roughing out the contour and the step that you saw in the foot peg mount. In Fusion, I used a 3D adaptive clearing toolpath that recognizes the whole geometry of the part, and it'll rough out all of the 3D surfaces. Here's Tool 4, or excuse me, Tool 3, 1/2-inch ball end mill, profiling that 3D step. Tool 4, our 3/8 chamfer mill, spot drilling our holes, and tools 5 and 6, drilling the holes. That's going to be it for now, guys. We'll catch you later.